the domain of the function. What are we not allowed to divide by? We can divide by a square root, but what am I not allowed to divide by? 0. I'm not allowed to divide by 0. So I got to figure out, since the x is in the bottom, my domain is not everything. Okay, I can't divide by 0, so something may make that bottom be 0. So I have to find my domain on number 75. I need to take x squared minus 5 and figure out, okay, I can't equal 0. X squared minus 5 is not allowed to equal 0. So we add the 5 to both sides. And we get x squared equals 5. Square root both sides, like we did earlier. So x is not allowed to equal positive square root of 5, and x is not allowed to equal negative square root of 5. And so they asked me to write this in set builder notation. So the set of all x such that x is not allowed to equal plus or minus square root of 5. We can list them each separate, or we can use that symbol to our advantage to make it a little bit shorter and sweeter. Okay? Interval notation, we would have to get the union involved. We would say from negative infinity to negative root 5, union, negative root 5 to root 5, union, root 5 to infinity. We'd have to have 3 intervals and stuff, because this is basically telling our readers that, hey, there's 2 numbers you can't use. You can't use the positive version of that or the negative version of that. That's what that's saying there. Every other number you can use. So interval notation will be really lengthy to show all the spaces. What graphically is going to happen at these 2 numbers on the x-axis? We're going to see jumping. We're going to see a gap. There's actually a vertical asymptote taking place at those locations. So we'll see it come in and graph, and then all of a sudden it'll go to one of the infinities, and then jump and go to the other part and come up from an infinity or whatever, and so forth. You know, this one might be something where it's like curved, U, curved. I don't know. I'd have to see what it looks like, but it had 3 sections to it, and is what it ended up being and stuff. So, boom, 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 boom. All right, there's your domains. We don't care about the top; it's the bottom. So, on 77 and 78, we just set the bottoms not equal to 0 and factor and solve. Or use the quadratic formula to find the 2 numbers that are not allowed to be used. Okay? Do you want me to do 78? You want me to do 78? Yeah? Okay. Here we go. 78. 78. Do it in blue. So the bottom, I'm going to use x's. 2x squared minus 11x minus 21 is not allowed to equal 0. Coach is thinking. Yeah, it's factors. So this does factor. We could use quadratic formula, but it does factor. What Coach sees here. Whoop, not once. I wasn't supposed to be a 1 there. So 21 is 3 times 7. 2 is 1 times 2. So what I saw that 2 times 7 is 14. And 1 times 3 is 3, and when I subtract, I get 11. So that's what I saw real quickly when I was looking at what numbers I had there. Yeah, there were factors of 21 to where when I multiply carefully and subtract, I do get 11. So I know my AC method there, those are the 4 numbers, but I need the 7 to be negative because I need my answer to be a negative 11. So that means as I look at this, that needs to be a positive, that needs to be a negative. So that's a negative 11. So negative 7 plus 3. So 3 goes there, 7 after the minus sign. We got to do 2 times 7, so 2 has to be in front of the x with the 3. Because you never multiply things in the same parentheses. You two got to stop whispering because I can hear it, so it's got to be messing the people up in front. Messes me up. All right, now. What can it not equal? X is not allowed to equal negative 3/2, and X is not allowed to equal 7. I just jumped through the ZPP real quickly and just said, well, it's the opposite of what's inside. So the opposite of negative 7 is 7. The other one, I kind of mentally subtracted 3 divided by 2. Okay, to get the X by itself. And then again, we would put that into set notation. The difference is we would write them both down and stuff. X can't equal this, and X cannot equal this, or this. So interval notation, remember that's where we're using, probably going to have to use the unions is what we're going to have to do. Let's look at 84. 84. And so as we look at 84, x squared plus 1 is not allowed to equal 0. Negative 1, negative 1. X squared equals, can't equal negative 1. I square root both sides. So technically, if we did our process of using the square root method on the bottom, we would find out that x is not allowed to equal plus or minus I. But we already said earlier today that I is what? It's square root of negative 1, but it's imaginary. So on an xy plane, can you graph an imaginary number? No. Okay, so is there a number that we cannot use in this problem? No. So technically my domain for this one would be what? It'd be all the infinities. Negative infinity to positive infinity. It'd be all reals. Okay? So there are times when we get it. That's why we got to set the bottom not equal to 0 and solve. So in this case, my domain, on this one, my domain is negative infinity to positive infinity. Because they said in interval notation. Interval notation means I want that parenthesis stuff. Make sure you got negative infinity to the left of a comma always. All right? Some of you in between this class and last class didn't. You put it on the right side of a comma, and I had to mark you wrong. Okay? It's negative on the left, positive on the right. Okay? And if you don't know your lefts and your rights, then that might be your parents' fault. So like my wife, she sometimes doesn't know lefts and rights and up on the map and going places because her mom taught her wrong. Like whenever her mom says, hey, you're going to go down to, New York. I'm like, okay, New York's up on the map and stuff. So, but she does that everything, and you always go to the opposite of what she says and stuff. If it's in a house, it's in the cabinet to the right of the stove. You go to the left of the stove, is what I've learned over the years. So, the discriminant. The discriminant helps us determine how many real solutions there are. Do you have one? Do you have two? Or do you have no real solutions? Two real solutions means my graph touches the x-axis twice. One real solution means the vertex is on the x-axis. No real solutions, which means imaginary, means that my parabola is above or below the x-axis and opens up away from it. So it never touches it. That's what no real solution means. So if you get I in some of these answers when we do stuff, that means that picture of the parabola should be somewhere to where it never touches the x-axis. It's in a direction somewhere to where how it opens, either it's shifted up, opens up, and it never touches below to the x-axis, or it's somewhere the vertex is below the x-axis and it opens down and therefore it can't touch it. That's what it means when you have I in your answer. You have no x-intercepts. Your parabola is not touching the x-axis. Okay? So the discriminant, instead of doing all of the quadratic formula, the discriminant is just what's inside the square root part, the b squared minus 4ac. If we can write this down next to it, because we're going to get out of here in 2 minutes. Okay? If b squared minus 4ac is greater than 0, so which means positive, two real solutions. If b squared minus 4ac equals 0, one real solution. If b squared minus 4ac is less than 0, so it's negative, 0 real solutions. So that would be the case that that means I is happening as you solve for stuff. I is taking place. Okay? So, tomorrow we start 3-4. We'll try to do some of the word problems here. I got to do a video on those 3 word problems on the next slide. And then we'll warm up with one of those tomorrow live.